right. So we're back after a nice little break. So you'll have a homework this week. It will be due on Friday. This week, Friday, you're going to have a summative quiz. It will cover everything that we've done so far in Unit 3, which is factoring, solving, exponents, and behaviors, and then whatever we're doing this week. So this week it's going to be more solving, but we're going to take the gloves off a little bit this week. So last week when we were solving, we gave you stuff that was easily factorable, or we gave you, like starting on last week, Thursday, actually no, last week, Monday and Wednesday, because we had classes. Monday and Wednesday, then we also said, like, there were 3 bus stops, right? Bus stop number 1 is you just straight up, it was a divide problem. Your choices were long division or synthetic division. Bus stop number 2 was you had to factor the polynomial completely. And then bus stop number 3 was you had to find all of the solutions. And in those, we always gave you something. We either gave you a solution, or we gave you a factor, or we just said straight up go out and divide it. Okay? This week, we're going to take that part away. We're just going to say, here is a polynomial, find me all of the zeros, or factor it completely, or something along those lines. Okay? And so we'll teach you how to do that this week. Okay? So in order to find all of the zeros, we have to take a step back to Algebra 2. And back in Algebra 2, you learned all about complex numbers. And when you were learning all about complex numbers, your teacher probably taught you one thing. And that one thing that they taught you was that I squared was equal to -1. Or they taught you that I was equal to the square root of -1. So we're going to open up imaginary world, and now we can find all of our solutions. Up to this point in time, we've only been finding real solutions. We've been saying if it's imaginary, we're not going to find it. We'll wait on that. Well, the waiting now is over, so now we're going to do this. What this allows us to do, or what these 2 facts up here allow us to do, is they allow us to find solutions. Now, you may have learned at some point in time, probably don't remember it, but a solution to a polynomial, an answer to a polynomial, a root to a polynomial, solution, root, answer, what's in fact? Oh, it'll pop back in my brain. All those to a polynomial are where the graph of that polynomial crosses the x-axis. That's where you find all of your answers, all of your solutions, all that fun stuff. Well, the downfall is that if you have, I'll just go a quadratic, if you have a quadratic that doesn't cross the x-axis, we still need to find 2 solutions for it because it's got a squared variable, a squared degree. Okay? So because of that fact that it never crosses down here, it never crosses that x-axis, we have to come up, or mathematicians, much smarter than I, came up with the imaginary concept. So I equals the square root of -1, or I squared is -1. Okay? So Where you probably used it a lot last year in Algebra 2 was your teacher or whomever, or on a test or on a quiz, they said simplify. Simplify the square root of -8. Okay? Which before, up to this point in this class, we just said, nope, doesn't exist. Can't do it. Okay? Now we're saying, okay, well, the square root of -8 is really the square root of -1 times the square root of 8. Okay? Well, the square root of 8 is really the square root of 4 times the square root of 2. So the square root of -1 is I, the square root of 4 is 2, and the square root of 2 is the square root of 2. And all of those are going to get multiplied together so that the square root of -8 is really 2I times the square root of 2. Number I radical. Okay? Not I number radical. Number I radical. Okay? And we will ask in this class that all of your imaginary answers, or actually all of your radical answers, are in simplest radical form, which square root of -8 would be wrong, 2I square root of 2 would be correct. Okay? So let's talk about a complex number. A complex number is made up of two parts. It's in the form a plus bi, where a is the real part and bi is the imaginary part. Okay. A true complex number has both of those parts, even if one of those parts is 0. So for instance, a complex number would be something like 3 plus 2i. It's got a real part 3. It's got an imaginary part 2i. A real number written in complex form, a real number would just be like 6. Okay? But when we write it in complex form, it would be 6 plus 0i. An imaginary number would be something like 2i, but writing it in complex form, it would be 0 plus 2i. Okay? So there are real numbers out there. There are imaginary numbers out there. But complex numbers have both a real part and an imaginary part. So if, for instance, we being me or Mr. Roth, asked for it on Friday's quiz in complex form, you would have to give us the 0, like it in real plus imaginary. NTC, on occasion, it's kind of been like every third type year, they have a question on the final where it says, give it to us in complex form. Okay? So with that being said, what I would like you to do now is I would like you to simplify those two, please. So this would be the square root of -1 times the square root of 49, which would end up being 7i. Questions on that first one? This one would end up being 2 times square root of -1 times the square root of 32. Square root of 32 is the square root of 16 times the square root of 2. So we've got 2, we've got 4, and we've got I all on the outside, and then we've got the square root of 2 still on the inside. So this one would be 8i square roots of 2. If you stopped at 4i square roots of 8, you didn't go far enough. Okay? You were going to Mosinee, and you were going to Stevens Point, and you stopped in Mosinee and said, I want to tour UWSP. It's not there, because you're on the way. You just didn't get far. Questions on either one of those? Bless you. Thank you. Try those two. So we've got 10, and we've got the square root of -1, and then we've got the square root of 28, but the square root of 28 is the square root of 4 and the square root of 7. Ten is 10. It's on the outside. It stays on the outside. Square root of -1 makes I come to the outside. Square root of 4 makes 2 come to the outside. And then the square root of 7 stays there. So on this one, I get 20 I times the square root of 7. Agree with that? -4 stays on the outside. Square root of -1 times the square root of 75. Square root of 75 is the square root of 25 times the square root of 3. -4 is -4, stays on the outside. Square root of -1 is I, moves to the outside. Square root of 25 is 5, moves to the outside. And then you have the square root of 3. So then this would become -20i square root of 3. Questions on either one of those two? Okay. So, we can now solve quadratics. Use the ones that can't be factored, we can solve them using I. Okay? So, a couple of different ways that you can go about solving this particular one. Since you don't have a linear term in it, you can first off subtract 6. Normally, if you had a linear term, that linear term being like an x term, like -5x or +7x, something like that in there, then you got to get it equal to 0. But if you don't have that linear term where you just have a squared term, then you can get the squared term on one side and the numbered term, the constant term, on the other. That allows us then to take the square root of both sides. Now my question from the start, should I ask this first, but I didn't. How many answers do we need? We need 2, because our degree is 2. So if I just take the square root of -6, how many answers am I going to get? If I just take the square root of -6, I'm just going to get 1, right? Okay. So when we're solving and we take the square root, what do we have to add in? Plus or minus. Okay? Anytime that we're solving and we take a square root or an even root for that matter, we have to add in plus or minus. And so then this would be plus or minus the square root of -6. Which, then I can go over here off to the side, and I can say, oh, the square root of -6, that's going to be the square root of -1 times the square root of 6, which is going to be I square roots of 6. So my final answer back over here then would be x equals plus or minus I square roots of 6. And that gives me the 2 answers that you told me that I had to have. Had to have a positive, or it had to have 2 of them. So one is positive I square roots of 6, the other is negative I square roots of 6. Okay? Questions on that? You've done that probably a couple, 13, 14 times. Okay. So when you're presented with something like this, the first question that you should ask yourself is, how many answers do we need? 2, right? Because we got an exponent, the biggest exponent is 2, right? Okay. Second question, third question. Second question you should ask yourself is, I have a square term. Do I have a linear term? What is the linear term? 4x. So I've got a linear term. So I can't do this one the way we just did that last one. I can't do this one by the square root of that. Okay? So then in this particular case, I'm going to have to get everything onto one side, or some people might say set it equal to 0. Okay. So now we got it equal 0. First thing you should look for is if you can factor it. Are there 2 numbers in this world that multiply together to be positive 13 and add to be negative 4? What are the only 2 numbers in this world that multiply together to be positive 13? 1 and 13. Okay? And those don't, that would either give me to 12 or to 14. Okay? So we can't factor it. Well, what does that mean?
Quadratic form.
Quadratic form. Okay? So let's set up quadratic form. So we've got here x equals the opposite of b would be positive 4 plus or minus big square root negative 4 squared minus 4 times a, which is 1, times c, which is 13, all over 2 times a. Anybody need me to rewrite the quadratic formula for them? Opposite of b plus or minus square root b squared minus 4ac all over 2a. Okay. Remember when I told you 2 weeks ago that you should have memorized that one? Okay. Makes your life go a little easier. Okay. I'll reiterate that. Memorize the quadratic formula. It's going to make your life go a lot easier this entire unit. And class for that. Okay? So 4 is 4 plus minus square root negative 4 squared. 16. Okay. 4 times 1, 4 times 13.
60.
Nope.
Nope. You're right. 52.
52, yep. The way I remember it, there's 13 cards in a suit. There's 4 suits in a deck, 52 cards in a deck. 52. All over 2. 16 minus 52. Negative 36. Oops, I put 6. I should have put negative and a 3 in front of it. Can I simplify the square root of negative 36? What does it simplify to be?
6.
6i. So it would be 6i. I always comes last. Okay? Even in our alphabetical, when we're doing multiple variables, I now doesn't come after H. I, in the math world, comes after Z. Okay? Because it's a special variable. Okay? So this would be 4 plus minus 6i all over 2. Can I combine 4 and 6i into 10i? Why not? 4 is not an i. Okay? Same rules apply as variables, combining like terms and variables. Okay? Can 4 be divided by 2? Can 6 be divided by 2? Yes. So my answer here is 2, 4 divided by 2 is 2, plus or minus 3, 6 divided by 2, times out. 2 plus minus 3. Okay? Love it. Think. Okay? So, today's worksheet is two-sided. We've got 7 problems to do. You can, from last week and from what you learned today, you can do all of the front side. You can do all the front side. Back side, you're going to have to wait at least until Wednesday.